Okay, welcome to this lecture on bicycles analysis and Google Spreadsheets. We're going to learn both. This is a Google spreadsheet. If you'll notice, spreadsheets have things called cells. This is cell A5, B6, so on and so forth. So right now in cell A5, we're going to type the word given. Hit enter, and I'm going to just bring up some other stuff right now. So you go ahead and type these words into each one of these cells that you see here, and when you're done, go ahead and put the recording on pause for right now, and then when you're finished you can unpause it. Okay, we'll pause now. Okay, so as I mentioned, each cell you can put either a word or a number. And in this cell, B6, the front pedal force, we said was 60. Notice I have my word, number, word. If I put 60 pounds here, then it will treat it as a word. So you can't mix up numbers and words. Okay, so 60 pounds, front pedal radius was 8, 5, to 14. Okay, now 2 pi, what we're going to do is we're going to show the formula. So right here, I'm going to go up here, I'm going to say 2 pi equals, I can say 2 times the pi function. Okay, and it knows what it is and it tells me what it is right there. All good. And I'm going to have 1 revolution, and therefore my theta, and as I'm saying this, I'm showing you how to do things. In this cell, I'm going to multiply 2 pi times 1. So I'm going to say this cell, I can either start off a mathematical operation with the equal sign or the plus sign or the minus. So I'm going to say this equals this times, and then I come up here and say this, and then I get that number. Okay, now if I don't want it that long, you can also go right here where it says decrease decimal places. 6.28 is fine. I don't even want a there. Okay, so now we have our numbers and everything like that. I'm going to come back in just a second and bring in the rest of the words that we're going to put in here. So hang on. Okay, so now I've typed in the rest of the words that we're going to use. So I'm going to let you just type all these in at the cell places where I show them. And from there we can go over there. So I'm going to go ahead and pause now and type the rest of these words, and then we will go ahead and get started again. All right? Okay, so now we're going to start doing math. Okay, and here notice I've got the pedal and the front sprocket, and this is what we're going to make as our first wheel and axle. Then from the front sprocket to the rear sprocket, that's our transmission, and then our rear sprocket to our rear tire, that is our second wheel and axle. So what I want to show is that the force on the pedal is 60 pounds. So all I got to do here is say this equals this. Okay, now if I make a change here, it will show up over there. So I'm going to keep that 60, and boom. So all we're saying is this cell, if you'll notice this cell equals whatever is at B6. Okay, so that's my force. And my distance, what I'm going to have to do is I'm going to have to say, I'm going to look at this equation. Theta equals distance divided by radius. So therefore, distance will equal theta times radius. So I'm going to say this equals theta times my radius. And the radius that I want is the radius of the front pedal. So I get that. The torque is force times radius. So I can say this equals my force times the radius, boom, And finally, theta is going to be theta. So I'm just simply going to say, so right here, I'm going to just say this equals theta. And there we go. Now I'm going to do a little more math. I'm going to show that my work rotational and my work linear are what they are. So if you remember, linear work is equal to force times distance, boom, and rotational work is equal to torque times theta, and boom. And I'm going to reduce the number of decimal points. 1 decimal point is fine for all of these. So there's that. Okay, so now what I want to show is that from the wheel and axle, remember we said before that torque and theta remain the same, but the force and distance will change on the wheel and axle. So right here I can just simply say the front sprocket theta equals the rear sprocket theta, and torque equals torque. Now what I can do is I can say, all right, what's my new force and distance? Well, force again is here torque equals force times radius, so torque divided by radius would be force. So I'm going to say my torque, which is this, divided by the radius, but this time it's the radius of the front sprocket. Boom. And my distance is going to be equal theta. This time it'll be theta times radius is the distance. So theta times the radius of the front sprocket. Boom. And now here's our sanity check. If we did this right, then I can copy these two equations, bring them over here, and I should get the same. Ooh, I get a different number. All right, so what do we get here? Now the nice thing is I can hit F2, and that tells me what I'm multiplying. Linear is right. Okay. Oh, I'm doing something wrong here. This is equal to theta times the radius of the front sprocket. Oh, which is 5. Sorry. And there we go. Now, okay, now you see these numbers are all working out. What I want to show here is, first off, work in equals work out, rotationally and linear. Also, again, this is a wheel and axle. It's a machine, a force multiplier. Look, I got 60 pounds in. I'm getting 96 pounds out. However, my distance is less than my original distance. Okay. Now, I also want to show that these two things are the same. So I'm going to highlight this, and I'm going to come up. So I look at fill color, and I will just go ahead and put yellow, showing that this and this are the same. Now, remember, in transmission, force and distance are the same. So I'm just simply going to say this equals this, and this equals this. I say equals, but you can use the plus sign as well. And I want to show that these two are the same, so I'm going to select my highlight color and just choose a different color. All right. Finally, I'm now going to calculate the new rear sprocket torque and theta, because remember we said force and distance is the same between the two sprockets, but because their radii are different, their torques and theta will change. But it's the same thing. Torque equals force times radius. So force equals torque equals force, this is my force, times the radius. And this is the radius of the rear sprocket, which is only 2. And theta will be the distance, which I have right here, divided by the radius. And again, I'm talking of the radius of the rear sprocket. Boom. And let me put this here. And did I do my calculation correctly? I can now copy these over, and I'm still good. And now what I want to show is, again, from the rear sprocket to the rear tire, this is a machine. So once again, torque and theta remain the same. I'll just give it a different color. Okay, and I'm simply going to copy this to this. This equals that. Okay, and now I'm going to calculate my last force and distance. So force will be torque divided by the radius. So I take my torque, divide it by the radius, but this is the radius of the rear tire, and my distance is going to be theta times the radius. So there's my theta times the radius, and the radius of the rear sprocket. Boom. And once again, bring these down to some numbers that are we understand what they are. Okay, and last sanity check. Did I do this correctly? Yay, my numbers. Okay, so first thing I want to show from here is the work in does equal the work out all the way through the system. Secondly, our mechanical advantage is the force out over the force in. So my mechanical advantage is my force out divided by my force in. And lo and behold, hey, I'm getting actually a number less than 1. So I'm not gaining any force out of this. This is not a force multiplier. So if I'm not getting a force multiplier, what am I getting? I'm getting distance. I'm going to take this number and say 1. Oh, now again, if I just simply said 1 divided by this, I would simply get the symbol 1 divided by. So again, I have to tell Google, I have to tell the spreadsheet I'm doing math. So once again, I have to start off with the plus sign or the equal sign. This equals 1 divided by this. And now I get this number. And here's why I ride a bike. For every 1 revolution I turn the front pedal, I get 4.375 distance gain. Okay? And that's why we ride a bicycle. Okay? Hope this has been helpful, and please review this, and now you can understand how spreadsheet works and how we just did our bicycle analysis. Now the nice thing is here I could change anything here. If I said, well, let me make my front sprocket 9, boom, we see all my new numbers come about. Okay, so that's why we love spreadsheets. I can change anything here and the entire thing recalculates. So this is great. Okay, so I hope you learned how to use Google Spreadsheets, and I hope you learn how we can analyze the mechanical advantage of a bicycle. All right, thanks much. Bye-bye.